Hello, my name is Zachary Strout, and this is the Physics 2212 Lab 3 magnetic field of a bar magnet. So a little report overview. First we're going to go through the introduction, then the experimental setup, then the data, the observations, calculations, the glow script code, conclusions, and then the discussion. So the purpose of this experiment was to measure the magnetic field of a bar magnet on axis as well as off axis, and to investigate the distance dependence of a magnetic field of a bar magnet, and then make a simulated model of the magnetic field of a bar magnet with Python and compare that simulated magnetic field to the measured magnetic field. Here are some of the fundamental equations, and the main results of this experiment were that the magnetic dipole moment was equal to 2.474 Newton meters over Tesla. And the measured off-axis magnetic field magnitude was equal to 5.36 times 10 to the negative 5 Tesla. The simulated off-axis magnetic field magnitude was equal to 2.41 times 10 to the negative 5 Tesla. And the magnitude of the net magnetic field increased as the distance decreased. So for the experimental setup, basically the goal was to find a distance from the magnet to a sensor that produced a magnetic field with an X component of various magnitudes ranging from 20 microtesla to 220 microtesla. And that is for the on axis. And then for the off axis, basically the same setup was used, but to find d perp, for which the net magnetic field had a magnitude of 100 microtesla, and then to create a 45-degree angle using this d perp, calculating d, and then using the magnetometer app to determine the x, y, and z components of the net magnetic field at this location. So here's our experimental data for the experiment, and as you can see in the graph on the right, that the natural log of the x component of the magnetic field versus the natural log of r, we got the equation y is equal to negative 2.9922 x minus 14.519. So some of the main observations of this experiment, we have that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction, as well as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. And this can be seen in the distance dependent equation of b bar is equal to kr to the n power. So some of the most significant calculations in this experiment, we use the equation b is equal to k times r to the n, and equated that to the magnetic field of a dipole on axis, and using that we found that the magnetic dipole moment is equal to 10 to the 7th times k r to the n plus 3 power over 2. And then using our equation in the graph, that y is equal to negative 2.9922x minus 14.519, we found that n is equal to negative 2.992, and that k is equal to 4.95 times 10 to the negative 7. Plugging those values into the equation we found earlier, we found that the magnetic dipole moment was equal to 2.474. So here's our glow script code for the experiment. And as you can see, a average d perp value of 0.179 was used to get an average d of 0.253144, and the magnitude of b at the 45-degree angle at distance d was equal to 2.411 times 10 to the negative 5 Tesla. So for our conclusions, obviously the computational model gave us a net magnetic field of 2.41138 times 10 to the negative 5 Tesla, but our measured net magnetic field was 5.35959 times 10 to the negative 5, which are honestly pretty close values considering um, they had the same decimal. So some errors or areas of possible error were nearby electrical equipment accidentally bumping into the smartphone, which had the application, failing to line up the smartphone with north before starting, or other objects that may interfere. For the discussion, what if you hadn't oriented your experiment to compensate for magnetic north and instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? The results for BX would be different due to interference from the magnetic field of the Earth, and the off-axis results would be different and inaccurate. The X and Y components would be different, but the Z component would not change since the meter stick is laid flat. And what if you were to stick two identical magnets together end to end and run the experiment again? So these measurements would differ because the magnetic dipole moment would have a different value, and the magnetic field would increase and be approximately double, and this would cause a decreased measured distances for the magnetic fields. And that is all. Thank you.